Welcome back, everyone. Today we'll be talking about the distributive property with both, and you'll see examples with both numbers and variables. Okay, so if you haven't heard of the distributive property before, it's the rule that states for any numbers, say you have like A and then times the quantity B plus C. And I say the quantity because this is in parentheses, and if you remember order of operations, it means that has to that's getting grouped together inside of parentheses. But this property can be helpful because if you don't know what the numbers are, like if you're using it with variables, you can't combine B plus C because we don't know what it is. But we can simplify this expression more with the distributive property, which says that you distribute and multiply in this A to the B and to the C, and you multiply both of them. So we'd have AB and then AC from those, and then you keep the sign that's in the middle of them. In this case, it's an addition sign, so you'd keep that sign. Say that it's very similar if you had A times B minus C. Once again, you distribute via multiplication that A to the other two variables inside. So you're left with AB and AC again. However, there's a minus sign in the middle, so you keep that minus sign in between them at the end. So it's pretty straightforward. It can be really helpful. It can be really helpful if you have, even if you don't have variables, like if you just have numbers. If you added the numbers in the parentheses first, it could be a bigger number than you're used to dealing with, and it could make it harder to solve. So let's go through some examples with the distributive property. The first one says 7 times the quantity 15 plus 8 is equal to 7 times 15 minus 7 times 8. Well, let's try this out for ourselves and see what we get. If we consider the 7 times the quantity 15 plus 8, if we did what I just explained, because it works just the same for numbers too. It doesn't just have to be for variables, because variables just represent numbers that you don't know. The 7 would get multiplied to the 15 and to the 8, so you'd have 7 times 15, and then over here you'd have 7 times 8. However, there's a plus, there's an addition sign in the middle, so you'd have to keep that addition sign. It wouldn't change to a subtraction, so this one is actually false. And this can be helpful, like if it didn't ask us if it was true or false, it asked you to solve, it might be helpful to do 7 times 15 plus 7 times 8 like this and then add them together. It might be easier to do for you than multiplying 7 times 23. If you were to go by order of operations and simplify what's in parentheses first, it might be easier that way. It's up to you. And in that case, when you're dealing with strictly numbers, just keep that in mind, like when you're dealing with like whole numbers, or like not even with whole numbers, just with numbers that aren't in the form of variables. You can still use order of operations and add what's in parentheses first and then multiply, but it might make it easier in this case, because if you know what 7 times 15 and 7 times 8 are, you can simplify it further without having to multiply with bigger numbers. That's just a thought to carry you through. Okay, so the next one is also true or false. The quantity x minus y times z is equal to xz minus yz. Is this true or false? Okay, so once again, let's do this. If it helps, multiplication is commutative, meaning you can multiply in any order. So I'm gonna switch the z to be in front just so it's consistent with what we were doing before. You're welcome to do this too. Just always be careful. If some kind of quantity is inside parentheses, you have to move the whole quantity over. Like notice how I kept x minus y together in parentheses, didn't change it. I just moved the z in front. You just make sure you stay consistent. Once again, we're going to distribute via multiplication. So the z is going to go in and the z is going to go in here. So we are going to have xz and y times z. And then there's a subtraction sign in the middle, so we're going to keep that. So this one's actually true, because when you distribute it in, that's what we get. And that's how you would go about checking something like that. When they ask you for true or false, just evaluate it for yourself and see if you get the same answer. Okay, so for the next bit of problems, they are talking about factoring. And factoring is essentially just the distributive property in reverse. It's just a reverse distributive property. And what I mean by that is when you're talking about factoring something, you're talking about getting a common factor out of it, of all of the items that are separated by addition or subtraction. So say you had like a b plus ac, like we ended up with up here after we did the distributive property. So when you do this down here, we notice both of these things have an A in them. The B and the C are different, but both of these terms, AB and AC, both have an A. So we can divide out the A from both terms and note it out here. And then all we're left with is the quantity B plus C. And if you redistributed the A in there, you would get what we had before, AB plus AC, via the distributive property. And the kind of idea behind this is you're noting it in a different way. You're factoring out, or you're dividing out the common term of A, and the opposite of division is multiplication. So you're noting it then as multiplication times what we had before. Or in another case, I want a different color just to demonstrate a different point. Okay, say you had a squared b plus ac. In this case, the common term in both of these is still the a. However, it's just a, not a squared. We don't, because both terms that are separated by the plus sign have an a in them, but only this one has two a's and an a squared. Because you could rewrite this as a times b plus ac. Now, if we factored out the common term, which is just a single a, we'd still be left over with one. So we divide an a out of both of these, rewrite it out front, and then what we're left with is ab plus c. So that's important to note too, that you always have to, I guess, like factor out with the least amount, and like go with the lowest one, or the lowest possible factor that applies across the board. And you'll see more examples of that, as we go on as well. Okay. So for number 3, it's asking us another true or false. It says 15ab squared minus 9ab squared equals 15 minus 9a times b squared. Okay, so true or false? Well, in this one, if we're going to evaluate it, we want to look at what both of these, we want to look at what 15ab squared and what 9ab squared has in common. And it has the ab squareds in common. So you could factor out the ab squared, because both terms have the ab squared in it. So you'd have ab squared, and then that's all that's left then is the quantity 15 minus 9. So this one's true. One thing to notice about this one too is that since the variables are the same you could consider these like terms and just subtract the like terms, which you'd get the same answer, because if you do the 15 minus 9, you're going to get 6. This would equal 6ab squared, and you could get to the same conclusion if you just subtracted them. But you can only subtract them like that because they both have the same variables, and in the same way, like they both have the ab squared attached or being multiplied to them. The distributive property just kind of confirms what you've already done before, which, and combining like terms, it works this way. Okay, so now it says factor 20 minus 10x. Okay, so if we're factoring 20 minus 10x, we have to think about what 20 and what 10x both have in common. 20 doesn't have an x multiplied to it, whereas the 10x does. So we can't do anything with the variable. However, we know that 10 is divisible by 10, and so is 20. 20 is also divisible by 10. So we can divide both of these terms by 10 and note that out here, because we're reversing the division back in, or we're reversing this, or we're noting that we divided the 10 out, and saying that if you wanted the same expression back, you'd have to multiply it back in. And then 20 divided by 10 is 2, and then 10 divided by 10 is 1, and then the x is just left over. So all you're left with is 2 times x. And then if you apply the distributive property, you'd get 20 minus 10x back again. And that's why I say factoring is essentially the reverse of the distributive property, because once you factor, if you apply the distributive property, you'll get back what you had in the first place, and then it'll undo itself. Okay, so now we have to factor 27v squared minus 9v. Okay, so we have to consider what these have in common, or these two, the 27v squared and the 9v have in common, both in terms of the variable and like number factors. So we have 27v squared. Oh goodness, my stylus decided to stop for a sec. Okay, so we have 27v squared and 9v. We have to think about what both of those have in common. We know that they both have a v, except this one, or the 27 has a v squared attached to it, but it still has a v, because v squared is just v times v. And then we know that that 27 is divisible by 9. So both of these have a 9 that can come out. So what we're left with, what we know we have in common, is 9v, and then 27v squared divided by 9v. One of the v's cancels from that v squared, and 27 divided by 9 is 3. So we're left with 3v, and then 9v divided by itself is just 1. So we're left with 3v minus 1 in parentheses. And then if you redistributed to check, you'd get 27v squared minus 1. If you notice math builds, everything that you've learned before still applies. It's just this is a new way to think about it and a new way to apply it. Okay, so now we have 5y minus 3z minus 4y plus 6z. So in this case, we're just going to start by combining like terms. We know that the terms with the y can be combined and the terms with the z's can be combined. And to help kind of visualize, I'll change the order around a little. So we have 5y and then negative 4y, so minus 4y, minus 3z still, plus 6z, 5 minus, and then if it helps to think about now with the factoring, both of these terms have a y. So we can factor out the y, and we have 5 minus 4. And then in this case, we can factor out the z. And just be careful here with the subtraction sign, because if you factor out like a negative z, you have to change the sign in here. So I'm just going to keep it positive. just for the sake of not being confusing, and then we'll do we have -3 plus 6 left over. Okay, so now 5 minus 4 is 1, so we just have y times 1. And then we have plus z, -3 plus 6 is +3, plus z times 3. So this is all equal to y, because y times 1 is just y, plus 3z. And once again, if you don't like to, I guess, factor out to solve it, you can just know that -3 plus 6 is 3, and then keep the z attached to it if you go the traditional route of combining like terms. But this, once again, just reinforces this, that if you if you factor, it works just the same. It just validates what you already know. Okay, so now we have to simplify -2a times the quantity 4a minus 6b minus 4a times the quantity 6a minus 2b. Okay, so what we're going to do first here is we're going to distribute this -2a to both the 4a and the minus 6b, and we're going to distribute this negative 4a both to 6a and the 2b. Okay. So -2a times 4a, so we have -2a times 4a. Keep that subtraction sign in the middle. And we have -2a times 6b. And then we have minus 4a times 6a. I'm sorry, or we can, if it helps, plus a -4a times 6a minus a -4a times 2b. So if we start multiplying these out, -2a times 4a is -8a squared. And then -2a times 6b is -12ab, but minus a negative is the same thing as plus a positive. So we just have plus 2a times 6b, so we have plus 12ab. And then plus a -4a times 6a, that would be a negative or a minus or a negative 24a squared. And then we have minus the negative again, so that becomes, once again, plus a positive 4a. 4a times 2b is a positive. Sorry, hold on, that was a terrible plus sign that doesn't even look like one. Plus 8ab. So now all that's left is to combine like terms. Might help to rewrite them next to each other a little bit. So we have a squareds and we have ab's. So we have -8 a squared minus 24 a squared plus 12ab plus 8ab. And just to reinforce the idea that like factoring can work just as well for combining like terms, we know we have the a squareds both here. So if we factor out the a squared, we have a squared times -8 minus 24, because that's what's left, plus ab times 12 plus 8. And then we can simplify what's in parentheses. -8 minus 24, -24 minus 8, however you want to think about it, is -32. So we're left with -32 times a squared. And then 12 plus 8 is 20, so plus 20 ab. And that would be as simplified as we could get. All right, well, that is the end of this video. I hope it helped, and I will talk to you in the next one. Thank you.